thermal stress. Here in this topic, actually it is connected with mechanical properties of solids. This thermal stress topic is connected with what topic, beta? Mechanical properties of solids. If you observe in the chapter, we have a term called Young's modulus. Young's modulus. Why is Young's modulus? Actually, in mechanical properties of solids, to explain the elastic nature, what we have taken the source means modulus of elasticity. There are three types of modulus of elasticity. In that, one among them is Young's modulus. When length changes, when there is effect in length and elastic nature we have to explain, we use Young's modulus. So why is called as Young's modulus? It explains us the elastic nature. Now the Young's modulus formula from mechanical properties of solids, what we have is y equal to Fl by A into delta L. F into L by A into delta L. Here F is force, and here what is A? A is area of cross section. Area of cross section, we have to call it as area of cross section. Simply we must not call it as area, we have to call it as area of cross section. And L is length of that rod. You have taken one rod, initial length is L. So the rod, when what will happen, suppose it changes the length, delta L is change in length. A is cross sectional area, F is force. So this is the formula for Young's modulus formula from mechanical properties of solids. Okay, I hope you are clear with this formula now. Let us observe the temperature effect. So I have taken one rod here. This is one rod I have taken. This rod is placed between two rigid supports. This is one rigid support. This is one rigid support. So between two rigid walls, a rod is placed between two rigid walls, and it is fixed like that. It is fixed between two rigid walls, and the length of the rod is L. Area of cross sectional area is A. L is length of the rod, like that we have taken. Here already see, you can observe here the rod just fit between the two rigid walls. Just this rod fit in two rigid walls, just fit like that. So this is the information given in this page. So first what happened? I have taken one rod, and that rod is placed in between two rigid walls. Just fits between the two rigid walls. That is the information provided in this page. Now let us observe here what happened. I am taking here the two rigid walls and the rod is there. If suppose temperature is increased, generally previous case temperature was T, now the temperature is increased by delta T. So temperature increased means what will happen? The rod will try to expand. Whenever it is heated, temperature increases. The rod try to expand here. The rod always try to expand. But here it is fixed between two rigid walls. Those walls will not move. So here what happen? It has to change the shape. Like this. It has to increase its length means it has to change the shape. So here to have the increase in length, what will happen? Because two rigid walls, it may change the shape. So whenever temperature decreases, the rod contracts. Means what will happen, beta? This rod length is L. Now temperature decreased, length will decrease. Because temperature decreases, rod contracts, the length decreases. Obviously the rod falls down. Suppose here, if temperature increases, what will happen? temperature increases, the rod expands. Rod tries to push the walls with normal force. This rod is trying to push the walls. It's trying to push the walls with a normal force acting on the walls. The normal force acting on the walls is F. So trying to push the walls. That's the phenomena we observe here. Fine. So now, as rigid walls don't allow rod to expand from its original length, what is happening here? As temperature increases, F will increase to produce an elastic strain. So F will be the force. We are increasing temperature. There is a force increases to have elastic strain. Because of that elastic strain, the change in length, if I have taken it as delta L, the strain is produced, and the strain produces here what we can say from the delta L is small change in length. So that I am taking it as delta L. So we know from thermal properties of matter chapter expansion of solids, linear expansion. Linear expansion means we discuss with alpha. What is alpha? Coefficient of linear expansion. Alpha is coefficient of linear expansion. The change in length by original length into temperature change. So delta L by L I can write as alpha delta T. Coefficient of linear expansion, I have taken the help of coefficient of linear expansion, and I can write the formula as delta L by L is equal to alpha delta T. I think this topic is clear now. So we have delta L by L is equal to alpha delta T. Already we got about Young's modulus. Young's modulus, what we wrote the formula? FL by A delta L. From here, delta L by L is nothing but F by AY, F by AY. So this formula Young's modulus is there in mechanical properties of solids. I already informed you. It is very easy if you have therefore, that means already if the mechanical properties of solids completed, easily you will understand this formula. Young's modulus is nothing but longitudinal stress by longitudinal strain. Like that, formulae are there, and from those formulae we can write Young's modulus as FL by A delta L. So what happened here? Delta L by L is equal to F by AY. Delta L by L is equal to F by AY. So in previous page, if you observe delta L by L, I got alpha delta T. Delta L by L, what I got? Alpha delta T. Now, by Young's modulus information, what I got? Delta L by L is F by AY. So now equating these two equations, because in equation 1 and equation 2 delta L by L, LHS is same. As LHS is same, automatically we can say the RHS values are also same. What are RHS values? RHS values means there when we are taking Young's modulus, in that formula I got F by AY. When you are taking coefficient of linear expansion, there we got alpha delta T. So we equated those two RHS here. So from here I can write why I am sending this side. Why I am sending this side. Then I can write F by A is equal to Y alpha delta T. F by A is equal to Y alpha delta T. The force acting normal to the unit area, we call it as pressure. Here in this situation we are calling it as stress. For the rod it is expanding in that way. When there is a change in length, we also call it as stress. So this stress actually called it as because related to heat. The stress connected to what? Temperature difference. Delta T is what? Temperature difference. So connected to heat. So we have to call it as thermal stress. As it is connected to heat, the stress itself we are calling it as thermal stress. So force by area is called as what? Thermal stress. So the stress produced during the temperature difference, and we are calling it as thermal stress. Fine. So now here F by A is equal to Y alpha delta T. Suppose I have taken A other side, then what will happen? I will get this formula F is equal to Ya alpha delta T. F equal to Ya alpha delta T. So F is equal to Ya alpha delta T means this thermal force is equal to Young's modulus into area of cross section. Alpha is coefficient of linear expansion. Delta T is temperature difference. So this F is force. So I call it as the force connected to temperature difference, that we are calling it as thermal force. And the stress corresponding to here is thermal stress. So this is the topic of thermal stress and thermal force. So whenever the rod is placed between two rigid supports, the rod is suppose placed between two rigid supports and rigid walls, and it is allowed to expand when it is heated. The phenomena what we are observing, the force developed here is called as thermal force, and stress developed here is called as thermal stress. Delta T is temperature difference. Temperature difference. Like that, we discuss this topic here. I hope it is clear now about thermal force and thermal stress concept. Now, let us observe the next one is cubical expansion. In mechanical properties of solids, we have one more term called K. K is called bulk modulus. K is called as bulk modulus. So here now we are using this term K here. So whenever linear expansion, previous concept is expansion is called linear expansion. What we got? In linear expansion, thermal stress is Y alpha delta T. We are taking Young's modulus. Young's modulus corresponds to what? Linear expansion, length, change in length. Young's modulus corresponds to change in length. Alpha corresponds to change in length. So these are related to length, Young's modulus and alpha. So they corresponds to length. So we have got the formula for thermal stress as F by A equal to Y alpha delta T. Now what happened means, now we are telling that cubical expansion. Cubical thermal expansion means, cubical means what? Yes, volume expansion. Volume expansion we used to take gamma, because we have gamma is equal to delta V by V into delta T. In solids, we have alpha, beta and gamma in solids. Gamma is related to volume coefficient of solids. Volume coefficient of solids. So now, as the heading is cubical thermal expansion, the heading is cubical thermal expansion. The expansion is in terms of cubical means volume. So volume related, here the term is gamma. We must not take alpha. Alpha is linear and gamma is volume. And their Young's modulus indicates related to the length, and K is bulk modulus and it is related to volume. Bulk modulus is related to volume. Sometimes instead of K, they are also taking it as B. They are also taking it as B. This topic is also connected with mechanical properties of solids. This topic is very easy. What is bulk modulus? What is Young's modulus? Very easy if you have done with mechanical properties of solids. If you are not done with mechanical properties of solids and you are observing this topic, you will be getting confused. What is this K? K is nothing but bulk modulus. It is nothing but related to what? Volume expansion, volume change, volume change. So like that we can discuss here cubical thermal expansion. Cubical thermal expansion means we told it is related to volume, and when we are taking linear expansion, that is related to length, and there we got thermal force formula what? F by A is Y alpha delta T. Young's modulus coefficient of linear expansion. Here thermal stress is bulk modulus and gamma is coefficient of volume expansion of solid. If you want, we can also write here gamma is equal to 3 alpha. We can also write gamma is equal to 3 alpha. So K is, yeah, that is bulk modulus. When our volume, cubical means volume expansion is given, This is the way we have to select. And F by A is here thermal stress. F by A is the thermal stress. In cubical related, we have to use the formula. Thermal stress is K gamma delta T. K bulk modulus, gamma coefficient of volume expansion of solid, and like that we can give the information. I hope you are clear with this topic now. From starting what we discussed, once we'll observe. First, we told that this thermal stress concept is related to mechanical properties of solids, and I told Young's modulus concept. Young's modulus concept, and Young's modulus means related to length, linear. So again here, I have taken rod and placed it between two rigid walls. After that, what I did here, I have made this one to expand. So what will happen? Temperature is increasing. Temperature is increasing. It tries to expand. That phenomena we observed. Then we connected with alpha formula. Alpha is change in length by original length into temperature difference. After that, we connected with Young's modulus. By Young's modulus, and that one finally we got thermal force and thermal stress. Then at last we connected with the cubical expansion with bulk modulus. I hope you are clear with this topic now about thermal force and thermal stress.